Hello, Sherbel. Hello.
Hello,
Hello.
hello, hello.
Hi. Good afternoon.
Good afternoon.
Good afternoon. How are you today, Sherbel?
Um, I'm pretty good. Thanks.
Okay, that's good to hear. What did you do earlier before our class?
I I just I I just learned Chinese.
Really?
Right.
Okay. I
You
see.
see that emoji?
Yes, I see that. That's why I'm trying to imitate you. But mine is a lot.
Jean Carl. Now I believe your name is Jean Carl.
What?
Nothing.
Okay. Are you ready for our lesson today?
Ready?
Okay, I'll share my screen to you and tell me if you can see my screen.
Remember see your screen.
Yeah,
I
okay.
think
Okay, so today's lesson is all
I
about,
see.
let's review first, making and hearing sound. Again, when there is a sound, we can hear it, right? When can we hear a sound? Question. When can we hear a sound?
Yes, of course. We
When?
can.
That's the question, Sherbel. When can we hear a sound? What is that? Ew! What are you doing?
I'm just pretending to lick it.
Pretending? Oh, good. I thought you really lick it. You're a great actress. You make me believe that you really lick your palm. Okay, let's go to our science class now. Here, when can we hear a sound? When? The question is when.
When?
Mm-hmm.
Um, and,
When can we hear a sound? When it reach our... Okay.
yummy.
Look here. Look here. We hear sounds.
We hear a sound. When?
We hear...
A sound when we hear a sound when um on the TV.
on the TV.
When can we hear sound? We
Okay.
hear sound from the brick.
We hear sounds when vibrating air hits our
A
eardrum.
eardrum.
Okay.
Okay.
Again, can you read this? Very
This
important. You remember
this
this one.
this this.
Okay. One more time. Read it again.
We hear sound. Oh, when I hold on. We hear sound when vibrating air hits our eardrum.
Yes, very good. For example, as you can see in the big picture, a guitar is a object that vibrates, meaning it makes sounds. And then, of course, it goes through the air. And then it goes here in our eardrums, okay? When it
Hi.
reach our eardrums, we can hear sounds. Okay?
Năm pickleball. Okay.
Okay. Do you have any question?
Nah. Not
Mm-hmm.
question for
No
me. Yeah.
question. Okay. So next, let's go to the next topic. Can you read? Can you read this one? Sound and volume.
Sound and volume.
Mm-hmm.
Vibrating with a sound and volume. Vibration with a lot of energy makes loud sounds.
Okay. Vibrations with
That
lots of
just
energy.
means the harder you hit something, the louder the noise. Little energy, quiet or soft sound.
Mm-hmm. Do you
Large,
understand?
large energy, loud sound.
Okay. Can you give me example, Sherbel? Sherbel, can you give me example, please? Lots
For
energy make a
example,
loud sound. Meaning, if you don't hit it so hard, there will just be a small sound. Right?
right.
Okay. Can you give me example? Example that vibrations with lots of energy make loud sound. Example here, let's read it. Little
Little
energy.
energy, quiet or soft sound.
Yes.
Large energy, loud sound.
Very good. So meaning to say, the more energy the vibration has, the louder the sound. The more energy, the louder the sound. Okay? Very easy to understand, right?
Right.
Okay, now let's go to the next one. Volume decreases when you get further away. Can you read it again? What happens when you get away or go further away from the source of sound, the sound source?
Sound source.
Mm-hmm.
Mhm. Volume decrease when you get farther away.
Okay. So, meaning to say,
Sounds get quieter as you move away from the source of the sound.
yes, number
The
two.
vibration lose energy as they travel farther and farther.
Mm-hmm.
So if something is making a lot of noise but it's far away, it sounds quiet. But one, the large vibrations of the bell are transmitted through
Transmitted.
the air.
Okay.
Two, near the bell Two, near the bell is very loud.
Mhm.
Three, the vibration gets weaker as they get the farther from the bell. Four, far away is the sound is quieter. Did I speak fast?
Yes, but do you understand?
Yes.
Okay. So, my question for you, Sherbel. Do you have any question for me? If not, I have a question for you.
No.
No question. Okay. So, why is it, Sherbel, that when we go farther, it decreases the sound? Why is it?
Because it decreases the sound because It decreases the sound.
Mm-hmm. Why, when we go farther, it decreases the sound, meaning we hear not so loud, but just quiet or just a soft sound.
Because it's so far.
Because it's so far
Or
away.
yeah, and the sound would have been quieter, 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 quieter.
Okay, it is because, Sherbel, as you can see in the picture, the sound wave, this is what you call the sound wave, okay? This one, this is the sound wave. So the farther you are, the weaker the weaker the vibration will be from the bell. And if you go farther, really farther, you can't hear anything anymore because it's very far. You get it?
Get it?
Okay. Do you have any question?
No.
No question. If you don't have any question, I will now go to the next page. Remember, volume decreases when you get further away. Again, Sherbel, can you read this one? This is very important.
Huh?
Can you read this one? This is very important. Please remember.
Um, where? Volume decrease when you get farther away.
Very
Yeah.
good. Volume decreases when you get further away. And this one, vibrations with lots of energy.
Vibration with a lot of energy make a lot of sense. I
Okay,
do
very
that.
easy. Now, let's go to
Very,
the next
very,
page.
very easy.
Sound and pitch. Sound and pitch. What is a pitch? What is a pitch, Sherbel?
Peach.
Pitch. Yes. Pitch is the pitch is
Peach. 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 Peach.
is the high and the low of a note. That is a pitch. You're pranking me, Sherbel. I can hear you. Okay. Okay. Good thing to your bags. Your bags are moving. That's why I can say that you're not lagging. Okay. One more. I will give you time to read number one. Can you read number one?
The shorter the vibrating object, the higher of the pitch of the note.
The shorter the vibrating object, the higher the pitch of the note. What does it mean? Okay, let's look at A and B. This is A and this is B. String A,
String A.
okay?
String A. String A.
Mm-hmm.
Will give
Lower, lower.
the lower note because it is longer than B. This is B, so short.
Okay, very good. So string A will give lower note because it is longer than B, okay? Because Remember, the shorter the vibrating object, the higher the pitch of the note. Okay, for example here, this is A and this is B. Bottle A, what happened to bottle A, Sherbel? Can you read it? What happened to bottle A?
Bottle A. Bottle A will give a higher note because the vibrating column of the air is shorter than the bottle B.
Mm-hmm. Okay.
Go to your
All right. So, what does it mean? Can you explain to me? A and B? A and B. A and B.
Mm, it means it means
It means you don't know? Okay.
it. No. It means that the bottle A is give a higher note to B. No, B is shorter than A.
Okay, very good. That means to say the shorter the vibrating object,
B.
the higher the pitch of the note will
This is
be.
a bottle.
Okay?
This is a B.
Bottle A will give higher note because the vibrating column of the air is shorter than bottle B. Okay? That is the pitch, the high and low of a sound. Remember that, Sherbel, okay? Again, what is pitch?
Mm, mm.
What is
Uh,
pitch?
uh,
What is pitch again?
uh,
What is pitch? The high and low?
is the high and low. Is A is high and B
Okay.
is short. So that's means A is given higher note more than B. B is lower. No.
Very
Oh.
good. Because of the vibrating column. The vibrating column is just short, so the pitch is higher. Okay?
Okay.
Okay, now let's go to number 2. Just remember, the shorter the vibrating object, the higher the pitch of the note will be. Just like this in the bottle, this one is very short, right? The column of the air is very short, so meaning the vibrating object. What happened to your face? Okay. Now number 2, the larger.
The larger of the vibrating of the low of the pinch of a noise is
Again,
deeper.
the larger.
The larger vi the 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 larger the vibrating objects, the lower of the pinch of a note, it will be deeper.
Okay, do you understand? For example, here, this is a high note because it is just small. And larger, this is large, yes or no?
Yes.
Okay, this is large. This is large, so the larger the vibrating object, the
Okay.
lower the pitch of the note will be, okay?
All
Okay,
right.
for example, this is a high note because look at that. It's like a ukulele, I think. It's very small, so it gives high note. And this gives a low note because it's a large vibrating object.
Now I know. Can you go to one number one?
Number 1, you want to answer now?
No. Can you
Oh,
go
this one?
and up? Right.
Okay.
So this is A. So A is longer. How the heck I? Okay. Okay, this is okay. Lower, give the lower notes because it's longer than B. How about this? A.
Which one?
So A is smaller, but B is big. So the vibrating goes low. So A vibrating go higher, 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 higher,
The
higher.
pitch is higher. Okay.
This is short. Okay.
Okay. They're just the same. Now let's go to the third one. The tighter the string,
The
the
tighter
higher.
the higher of the pinch of the nose.
Okay, this is a loose string. Meaning a loose string is loose. Okay. And when we say tight string, very tight, almost no space.
Right. So, what is ping? Ping, ping, a guitar.
No. It's like a
This is
sound.
kind.
For
This
example,
is kind of like tuning of guitar. How about this? What is twang?
no, it's just the expression. It's just an expression.
And 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 what is this two?
Oh, just an expression too.
How about this?
That is the string.
And how about this?
Which one? An arrow? High
Yeah.
pitch.
And how about this?
It's just 1 kilogram, meaning to say it's loose string because it's not so heavy, so the string is not tight. But if you put a lot of kilogram, of course, it will be push here and push here. So over here is
So
very
why
tight.
this say? So why this say strong?
Oh, because when you touch it, it's like twang, twang, twang. But this one, if you touch it, it will say ting, because it's very tight. And tight string means a high
Do not
pitched
look like
note.
guitar to me.
What? It's like a
That don't look like
guitar.
it.
It's it's like how you are adjusting the guitar.
How, does this look familiar? That not look like a guitar to me.
Hmm. Why?
Here, that's not looks like guitar. Isn't guitar supposed to be like this?
Mm-hmm.
Yeah, but why is it like a bar now? See, this is the guitar. Guitar should be like this, not like this. So even like this, that's not the correct picture. Anyway,
Okay. Now let's read. Now it's your turn to pitch in. Learn this a lot. Okay, let's read. Right then. Let's read it.
now it's your turn to pitch it and learn this flat.
Mm-hmm.
First, question. Pitch just means whether it's a high note or a low note. It's none of this making any sense. Nonsense. And get your own self.
Get
Some
yourself
different size. Get yourself and different sizes.
of
Epic band.
elastic.
Elastic band and give them a twang, 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 twang punches. And small ones can be the high pitched sounds, but the big one will be a low pitch sound. Stretching to elastic bands make it tighter so the pinch will get even higher. So if the anyone asks if you want to go up to, just tell them what you're doing. You're doing science.
Okay, do you understand?
Yeah. I
Or are you
understand
sure?
very noise. Sure.
Okay.
And we go to number one again.
Okay, no problem. Why?
Um, I just want to answer those questions.
Okay. Are you ready now?
Ready?
Okay. So summary of questions. Summary of questions. Let's read question. Question number 1. Let's read it.
Summary question for the section 11.
Yes.
1. How is your sound produced? Produce the sound produced by
How is sound produced? A sound is produced
a sound is produced by
when there is a sound is produced when there is a
when there is when there is a when there is vibrating. Yeah, just vibrating things
yes plus
like breathe. Plus travels so through at the air.
plus it reaches our. Do you understand, Sherbel? Can you read it?
Vibrating object plus travel through the air reaches our eardrums.
Yes. Vibrating object, for example, a guitar. And when the guitar vibrating air. And then the vibrating air reaches our eardrums. That is how can we hear a sound? Oh, that is number 4, Sherbel. But number 1, how do we hear sound?
Name 3
No, no, no,
material
no.
that
Wait. Let's go back to how it how is sound produced. How is sound is produced?
how
Sound
is sound produced.
sound happens when
Sound happens when something vibrates.
okay, very good job. Sounds happen when something vibrates. Okay, as easy as that. All right?
Right.
Okay. Now, sound are transmitted through the air. This is what I'm talking about, or another material. And again, sound travels where? Let's have a review first so that we cannot forget when we answer. Can you review?
Sound can travel through sound can travel through all kinds of materials like stone, bricks, water, or glass.
Very good, very good. When can a sound cannot travel? When can a sound cannot travel? When can a sound cannot travel?
When the sound cannot travel.
Yeah, when? When it travels through a
It travels
when
through
it travels through a
stone, a
vacuum.
brick, a
It
vacuum.
cannot. I mean, it cannot. So stones, brick, water, and glass, sound can travel through it. But how about? But how about cannot travel? When there is a vacuum, a sound cannot travel. Can you read number 3, Charbel? Can you read number 3?
Sound cannot travel through a vacuum because is there nothing to transmit it the vibration.
Okay, very good. So now let's continue to our question now. We are in number 1. Again, number 1. How is sound produced? How is sound produced?
How is sound produced?
Mm-hmm.
How is sound heard?
How is sound produced?
So, how is sound produced?
Mm-hmm.
Okay, so sound produces by vibrating things.
Very good. Very good. Number 2. Name 3 materials that sound can travel through. 3 materials.
The
Number 1.
tone brings a glass of water.
And number 3 is
Breaks.
okay, good.
Isn't
Number
it?
yes. Very good, Sherbel.
And number
Okay.
3, name
Because you
one
are so
thing.
very, very good, Sherbel, I will give you a milk. Do
What?
you like to drink milk? I will give you a bottle of milk. This is a glass. Sound can travel through a glass. Okay, get it.
How
Yours.
about this?
It can travel through a plastic too. Yes, it can. Okay, number 3, let's read the question.
Name one thing that sound can't travel through and explain why not. A vacuum.
And explain why. It says here, why can't it not travel through a vacuum?
Because it's too loud.
It's too loud. Mm-hmm.
When we go to vacuum, we turn on the switch and then we vacuum the loud noise.
Okay. All
Oh,
right.
all right.
Here
All right, all
is the
right.
question number 4. How do we hear sounds?
Is that my
Question number 4. How do we hear sound? Don't
Don't
just
just
say,
say with our ear.
yeah,
Just give it a detail. I said, how do we hear sound? Oh, yeah. That girl is too shouting. Sing matters.
okay. How can we hear a sound? Go, go,
So
go.
how can we
Go, go,
hear
go,
a
go,
sound?
go. Mm-hmm.
So we hear a sound.
Mm-hmm.
How do we hear a sound?
Yeah.
Mm, How do we hear sound? This,
I explained
how
it
can
earlier.
how can we hear sound?
Yeah, I explained it earlier, Sherbal.
When we standing far away from my mom, my mom said, "Isabel, come here," and I just sent here. Um, mm, I cannot hear you.
Hello?
So so if
Oh.
so if so if the so if I'm standing here and my mom's standing here so far together, my mom says come here. So so this travels through, but quiet like this.
Like what like this? Hello? What do you mean like this, Sherbal?
How do we hear sound?
Mm-hmm. Yeah. How do we hear a
Okay.
sound? We hear sound when there is a vibrating object. And then when there is a vibrating object, it travels through the air. Okay?
Okay.
And then when it travels through the air, if it reaches
It's so
our
quiet.
if it reaches our ear,
Mm.
we can hear it. Okay?
Okay.
Okay. Where are you? I cannot see you. Do you have any question?